everyone, I am Recep Adiyaman, working with Professor Liam McGuffin at the University of Reading. Today, I will introduce our ReFol3 web server, designed for the refinement of the 3D models. We'll also talk about the refinement of the protein 3D models and the usage of the local quality estimation and contact prediction in our refinement pipeline, then the performance of the ReFol3 in CAS14, then the refinement of the SARS-CoV-2 targets in CAS-Common 2020, then the usage of the ReFol3 web server. The refinement of the protein 3D models aims at increasing the accuracy of the structure. The accuracy of the structure is very important for further computational studies, such as protein engineering and drug design. 8 of the top 10 groups were using the molecular dynamics-based approach in CAS14. The Morpho server has been ranked among top model quality assessment programs in terms of predicting the per-residue accuracy score in 3D models. The predicted per-residue accuracy score showing the predicted distance from the native structure in angstroms. We started to use this precision information since CAS13 to guide the molecular dynamics-based protocol of ReFol as the first attempt. Contact listing agreement between the contact prediction which were made using the metacycle method and the contacts in the 3D models, and it has been used as a local quality scoring method since CAS11 by the Morpho server. After the impressive performance of deep metacycle in CAS13, we propose to utilize the contact listing agreement score to guide the molecular dynamics-based protocol of ReFol. We also propose to use novel gradual restraint strategies by considering the required level of refinement for each residue according to predicted per-residue accuracy score and the contact listing agreement score produced by Morpho server in CAS14. The starting models were refined by 3 protocols. The first protocol is the usage of the IT-refine for the refinement of the starting model. Second and third protocol is the usage of the gradual restraint strategies based on the local quality estimation and contact prediction for the refinement of the starting model. All refined models were ranked using the Morpho 8 ranking option, and the top 5 models were submitted by our group during the CAS14 experiment. The green line represents the models generated by ReFol. As you can see, there are significant undesired deviations from the native basin according to GTHA score. The red line represents the model generated by ReFol2, which we tested in CAS13. As you can see, ReFol2 managed to not deviate from the native structure compared to ReFol1. In CAS14, we applied gradual restraint strategy based on the local quality estimation and contact prediction. The purple and blue lines represent the models generated by the gradual restraint strategies. It's clear that the usage of the gradual restraint strategies made significant progress directing the generation of the 3D models towards the native structure. If we can have a closer look at the improved models, it's clear that the number of the improved models significantly increased with the usage of the gradual restraint strategies. This was also observed across all CAS13 targets, and ReFol3 outperformed our ReFol1 and ReFol2 approaches in terms of the percentage of the improved models across all CAS13 targets. We also used the gradual restraint strategies based on local quality estimation for the refinement of SARS-CoV-2 targets. The best predicted 3D model identified by Morpho 8 was further refined by the gradual restraint strategy based on the local quality estimation. As you can see that significant proportion of the top 20 models for the SARS-CoV-2 targets provided by our group
during the CASP Common 2020, as you can see on more targets.
You can easily use our refinement web server for the refinement of your structure. You just only need your protein sequence and your structures, and the result will be emailed you in 48 hours. If you don't have your structure, you can use our info server. You just need only your protein sequence, then the result will be emailed you. After getting the structure from the info, you can refine it further using our refinement option. After getting a result from the refinement, you see that all models rank by the Moffat A global score, and you can visualize the improvements via the Perez error plots and the superposition of the input models with the refined model. In conclusion, refinement is our first attempt at utilizing the contact prediction, and the application of the gradual restraint has been also a unique and pioneering strategy for the molecular dynamic simulations. And refinement managed to improve the quality of the 70% of top server 3D models in the regular prediction category of CAS14. This is very important for a web server method. Our success in CAS Common 2020 also highlights the importance of the role of our prediction pipeline, and we can predict the structures and refine it further without requiring any other methods. Thank you for watching the video. You can also find more about in our references.